Hello everyone, welcome to Class 10 Geography. Today we begin a very important and meaningful chapter, Resources and Development. What if everything that makes your life comfortable, the food you eat, the house you live in, the clothes you wear, depends on how wisely we humans use our resources? In this session, we take a complete journey through the concept of resources and development. You will understand how resources are created through human effort, why sustainable development is essential for our future, and how resource planning shapes a country like India. We will explore land use patterns, land degradation, soil formation, major soil types of India, and methods of soil conservation. By the end, you'll see how geography directly connects to your everyday life. Everything you see around you, from the air you breathe to the gadgets you use, is part of a complex story of how we interact with our environment. Can we call just anything a resource? Not quite. Something in our environment that can satisfy our needs can be termed as a resource. But there's a catch. For something to truly be a resource, it must be technologically accessible, economically feasible, and culturally acceptable. Imagine finding a precious mineral deep underground, but having no machinery to reach it. That is not technologically accessible. Or imagine a resource so expensive to extract that it costs more than its value. That is not economically feasible. Finally, it must be something our society accepts. You see, the transformation of these environmental materials into resources isn't automatic. It involves a fascinating interactive relationship between nature, technology, and institutions. Think of it as a triangle with human beings right in the center. We are the active agents. We interact with nature using technology, and then we create institutions like factories or schools to speed up our economic development. Many people assume resources are just free gifts of nature, but they aren't. They're actually a function of human activities. We ourselves are essential components of resources because we are the ones who transform raw materials into something usable. To manage these resources, we first need to classify them. We can group resources in four main ways. First, on the basis of origin, we have biotic and abiotic resources. Biotic resources are obtained from the biosphere and have life, such as human beings, flora, fauna, fisheries, and livestock. Abiotic resources are composed of non-living things like rocks and metals. Next, we consider exhaustibility. Renewable resources can be replenished by physical, chemical, or mechanical processes. Think of solar and wind energy, water, forests, and wildlife. Some of these are continuous or flow resources, like wind and water. On the other hand, non-renewable resources take millions of years to form. Some, like metals, are recyclable, but others, like fossil fuels, cannot be recycled and get exhausted with use. Ownership is the third way to classify them. Individual resources are owned privately by people, like the land a farmer owns or a house in a city. Community-owned resources are accessible to all members of a community, like village ponds, village grazing grounds, burial grounds, or public parks and picnic spots in urban areas. Then there are national resources. Technically, everything within a nation's boundaries, including minerals, forests, and the ocean up to 12 nautical miles from the coast, belongs to the nation. Finally, there are international resources. These are regulated by international institutions. For example, the open ocean beyond 200 nautical miles of the exclusive economic zone belongs to no single country, and no one can use it without international agreement. Lastly, we classify them by the status of development. Potential resources are found in a region but haven't been utilized yet, like the massive solar and wind potential in Rajasthan and Gujarat. Developed resources are those that have been surveyed for quality and quantity and are already in use. Then there's stock, materials that could satisfy our needs, but we don't have the technology to use them. For instance, water is a compound of two inflammable gases, hydrogen and oxygen, which could be a huge energy source, but we don't know how to use them for that purpose yet. Reserves are a subset of stock. We have the technology, but we are saving them for future requirements like water in dams or forests. Resources are vital for survival and quality of life. However, because we assume they were free gifts, we use them indiscriminately. This has led to three major crises. First, resource depletion to satisfy the greed of a few individuals. Second, the accumulation of resources in only a few hands, dividing our society into haves and have-nots, or simply rich and poor. Third, it has triggered global ecological crises like global warming, ozone layer depletion, environmental pollution, and land degradation. To ensure a high quality of life and global peace, we need an equitable distribution of resources. If we continue as we are, the future of our planet is in danger. This is why resource planning is essential for the sustainable existence of all life. This brings us to the concept of sustainable development, which means development should happen without damaging the environment, and what we do today shouldn't compromise the needs of future generations. Back in June 1992, more than 100 heads of state met for the first International Earth Summit in Rio de Janeiro, Brazil. They addressed urgent environmental protection and socio-economic problems. They signed a declaration on climate change and biological diversity and adopted Agenda 21. This agenda is a plan to combat environmental damage, poverty, and disease through global cooperation. A major goal of Agenda 21 is that every local government should create its own local version of this plan. In a country as diverse as India, planning is a must. Some of our regions are rich in certain resources but lack others. For instance, Jharkhand, Chhattisgarh, and Madhya Pradesh are loaded with minerals and coal, but Arunachal Pradesh has tons of water and lacks infrastructure. Rajasthan is perfect for solar and wind energy but lacks water, and the cold desert of Ladakh is beautiful and culturally rich but lacks water and vital minerals. This is why we need balanced resource planning at every level: national, state, and local. Resource planning in India is a complex three-step process. First, we identify and inventory resources through surveying, mapping, and measuring. Second, we build a planning structure with the right technology and skills. Third, we match these resource plans with our overall national development goals. We've been working on this since our very first 5-year plan after independence. However, just having resources isn't enough. Without the right technology and institutional changes, development can stall. History shows that colonies were often targeted by invaders specifically for their resources, and those colonizing countries used their superior technology to exploit them. In India, Development is a mix of resource availability, technology, human resource quality, and our historical experiences. This leads us to resource conservation. Using resources too quickly or irrationally leads to socio-economic and environmental trouble. Leaders like Mahatma Gandhi were very concerned about this. He famously said, "There is enough for everybody's need and not for anybody's greed." He blamed the exploitative nature of modern technology and greedy individuals for resource depletion, and he preferred production by the masses over mass production. Internationally, the Club of Rome advocated for conservation in 1968. Later, in 1974, Schumacher's book, Small is Beautiful, echoed Gandhian philosophy. The 1987 Brundtland Commission report introduced the now famous concept of sustainable development in the book Our Common Future. Now, let's talk about land. It's our most fundamental asset. It supports everything from forests and wildlife to our transport and communication systems. But land is finite, so we must plan its use carefully. In India, our land is quite varied. About 43% is plains, which is perfect for agriculture and industry. Mountains make up 30%, ensuring our rivers flow year-round and supporting tourism. The remaining 27% is plateau region, which is rich in minerals, fossil fuels, and forests. How do we use this land? We categorize land utilization into several types. First, there are forests. Second, land not available for cultivation, which includes barren wasteland and land used for buildings, roads, and factories. Third, other uncultivated land like permanent pastures and grazing land, or land under miscellaneous tree crops. There is also culturable wasteland left uncultivated for more than 5 agricultural years. Fourth, we have fallow lands. Current fallow left for 1 year or less, and other than current fallow left for 1 to 5 years. Finally, we have the net sown area, NSA, the actual area where crops are grown. If you add the area sown more than once in a year to the NSA, you get the gross cropped area. The way we use land is determined by physical factors like topography and climate, and human factors like population density and technology. India's total geographical area is 3.28 million square kilometers, but we only have land use data for 93% of it. Why? Because reporting for most northeastern states, except Assam, is incomplete, and some areas in Jammu and Kashmir occupied by Pakistan and China haven't been surveyed. There are some interesting trends here. The area under permanent pasture has decreased, which makes us wonder, how do we feed our huge cattle population? Also, the pattern of net sown area varies wildly across states. It's over 80% in Punjab and Haryana, but less than 10% in Arunachal Pradesh, Mizoram, Manipur, and the Andaman and Nicobar Islands. Meanwhile, our forest cover is about 23.4%, which is much lower than the 33% target set by the National Forest Policy of 1952. This target is essential for ecological balance and the livelihoods of millions. Unfortunately, we haven't always treated our land well. About 95% of our basic needs come from the land, yet human activities have caused significant land degradation. Human activities like deforestation, overgrazing, mining, and quarrying have made things worse. In states like Jharkhand, Chhattisgarh, Madhya Pradesh, and Odisha, mining has left deep scars on the earth. In Gujarat, Rajasthan, and Maharashtra, overgrazing is the main culprit. In Punjab, Haryana, and western Uttar Pradesh, over-irrigation has led to waterlogging, which increases salinity and alkalinity in the soil. Industrial dust from cement and ceramic industries also makes it harder for water to seep into the ground. But we can solve this. Afforestation and proper grazing management are key. In arid areas, we can plant shelter belts, control overgrazing, and stabilize sand dunes by growing thorny bushes. In industrial areas, proper treatment of effluents before disposal can reduce both land and water pollution. Next, let's look closer at the earth beneath our feet, soil. Soil is a living system and a most important renewable natural resource. It takes millions of years just to form a few centimeters of soil. Its formation is influenced by relief, parent rock, climate, vegetation, and time. Natural forces like temperature changes, running water, and decomposers all play a part. If you look at the soil profile, you'll see layers. The topsoil, then subsoil, silt and clay, then weathered parent rock, and finally, the unweathered solid bedrock. In India, our varied relief and climate have created several types of soil. First, alluvial soils. These are the most widespread and fertile soil. They cover the entire northern plains, deposited by the Indus, Ganga, and Brahmaputra rivers. They also extend into Rajasthan and Gujarat and are found in the eastern coastal deltas of the Mahanadi, Godavari, Krishna, and Kaveri. These soils contain sand, silt, and clay. Near river valleys, they are fine, but in upper reaches, they are coarse in nature. We classify them by age. Old alluvial is called Banga, containing more conker nodules, and new alluvial is Khada, more fertile and fine. Alluvial soil is ideal for cultivation of sugarcane, paddy, wheat, and pulses. Second, black soil, also known as Riga or black cotton soil. These are typical of the Deccan Trap region, formed from lava flows. They are clayey, hold moisture well, and are rich in calcium carbonate, magnesium, potash, and lime, but poor in phosphorus. They develop deep cracks in hot weather, which helps with aeration, but they get very sticky when wet. Third, red and yellow soils. Red soil develops on crystalline igneous rocks in low rainfall areas of the eastern and southern Deccan Plateau. It turns red due to iron diffusion and yellow when it's hydrated. Fourth, laterite soil. The name comes from the Latin word later, meaning brick. These soils form in tropical climates with alternate wet and dry seasons due to intense leaching from heavy rain. They are acidic and generally poor in nutrients, but with proper conservation, they are great for tea, coffee, and cashew nuts, especially in states like Karnataka, Kerala, Tamil Nadu, and Andhra Pradesh. Fifth, arid soils. These range from red to brown and are sandy and saline. In some places, salt content is so high, people opt in common salt by evaporating the water. They lack humus because of the dry climate. The lower layers have conker because of high calcium, which blocks water infiltration. However, with irrigation, they can become cultivable, as we see in western Rajasthan. Finally, forest soils. These are found in hilly, snowy areas. They are loamy and silty in valleys, but coarse on upper slopes. In the Himalayas, They often experience denudation and are acidic with low humus, but they are very fertile in the lower river terraces. The final piece of our story is soil erosion, the washing away of the soil cover. While soil formation and erosion usually happen at the same rate, human activities like deforestation and mining disturb this balance. Running water can cut through clay soils, creating deep channels called gullies. This creates bad land. In the Chambal Basin, we call these as ravines. Sometimes, water washes away the top layer of soil over a large area, which is sheet erosion. Wind can also blow away loose soil, especially on flat land. Even wrong plowing methods can create channels for water to wash away soil. But we have the tools to fight this. Contour plowing, plowing along the natural lines of the land, slows down water. Terrace cultivation, where steps are cut into slopes, is very effective in the western and central Himalayas. Strip cropping involves leaving strips of grass between crops to break the wind's force. Finally, planting lines of trees to create shelter belts has helped stabilize sand dunes and deserts in western India. To summarize what we've learned today, resources are not free gifts of nature. They become resources when humans use technology and institutions to transform them. Sustainable development ensures that present needs are met without harming future generations. Resource planning is essential in a diverse country like India. Land is a vital but limited resource, and improper use leads to degradation. Soil supports life and exists in different types across India. Soil erosion threatens productivity, but can be controlled with proper conservation methods. Above all, remember Gandhiji's message: there is enough for everyone's need, but not for anyone's greed. Understanding resources means understanding responsibility. When we conserve resources, we protect our future. Thank you for joining me for this geography session. If you feel the video helped you in understanding the chapter better, please like, subscribe, and share it with your classmates. We will continue our learning journey in the next video. Until then, take care. Bye.